If a stone is dropped from the height of 400 feet, its height after t seconds is given by the function s of t equals 400 minus 16t squared. Find its average velocity over the period 2, 4, and then estimate the instantaneous velocity at time t equals 4. Recall the average velocity is f of b minus f of a over b minus a. In this case, the function f of t is 400 minus 16t squared, and with the given interval a equal 2, b equals 4. And so this is f of 4 minus f of 2 over 4 minus 2. To evaluate this expression, we would need to know what f of 4 is. F of 4 is 400 minus 16 times we substitute t with 4. And this will give us 144 using a basic calculator to compute this. F of 2 is 400 minus 16 times 2 squared. Again, using a calculator, we should get 336. We then put these back into this expression. We replace f of 4 with 144, and we replace f of 2 with 336 over 4 minus 2 in the denominator is 2. 144 minus 336 is negative 192 over 2. And so this is negative 96. And the units of this average rate of change is the unit of the numerator, which is position or the height in feet. And the unit in the denominator is the unit of time t, in this case, second. And so the average velocity over the period 2, 4 is negative 36 feet per second. For part B, we're looking for the instantaneous velocity, which is, by definition, it is the limits at h go to 0 of f of a plus h minus f of a over h. For this section, we are not going to compute this expression. Remember that a, in this case, is the point in question, which is t equals 4. So we replace t with 4. The limit is at h equal to 0 of f of 4 plus h minus f of 4 over h. Again, instead of evaluating this, we will estimate it using h equals 0.0001. For estimation, it suffices to use this small value of h. And so the approximation for this instantaneous velocity is now f of 4 plus 0.0001 minus f of 4 over h, but h is 0.0001. This is an approximation to this limit, so we drop the limit notation. This is now f of 4.0001 minus f of 4 over 0.0001. We still need to evaluate this expression to approximate the instantaneous velocity, where f of 4.0001 is, we plug this into the given function, 400 minus 16. T is now 4.0001, and then we squared it. If we plug this in a calculator, we will get 143.9872. It suffices to give 4 decimal places in the intermediate step. Earlier, we also computed f of 4, and we saw that f of 4 was 144. Putting this together, we have f of 4.0001 is 143.9872 minus f of 4 is 144 divided by 0.0001. In the numerator, it is negative 0.0128 over the denominator is 0.0001, and this is negative 128. The unit is still feet per second. The unit of the instantaneous velocity is the same as the unit of the average velocity. Even though this is an approximation to the instantaneous rate of change at t equals 4, in the near future, we will see that this is a very good approximation. In fact, the precise instantaneous velocity at t equals 4 is negative 128 feet per second.